Let's go through an example that uses traditional hypothesis testing. It says a researcher believes that the average number of hours a person spends in traffic each year is more than, that's going to be important, more than the national average of 46. Assume the population standard deviation is 3.6 years. A random sample of 30 subjects is selected and the mean number or the mean time of the sample is 47.8 hours. Test the claim at alpha of 0.05. Okay, if you haven't watched the overview for the steps on this, you might want to go back and watch that. If you have, you know there are 5 steps. We are going to start with step 1, and in step 1, we identify our null and alternative hypothesis. So we're going to say H sub 0. Okay, now let's stop and think for a second. Remember, in this chapter, we have choices of they can be talking about means and averages, they can be talking about percentages and proportions, or it can ask you about standard deviation and variance. This particular one is talking about averages. And my sample size is 30 or more, so that's going to make a difference. When they're talking about averages, we use the symbol mu. Remember the the null is always equal to. So we're going to say H sub 0 mu equals 46. And then we're going to say H sub 1, put our mu. If they said more than, they mean greater than. So we're going to say mu is greater than 46. Remember, you have 3 choices for that. It can be less than, greater than, or it can be a not equal to if they use the word differs. In this case, they claimed that it was more. So they are claiming the alternative hypothesis. Our next step, we are going to draw our curve. And my artwork is not good, so I am going to drag a curve over here. We are going to look at our curve and we are going to shade this curve to the right, because it is a greater than. Remember the alpha, the amount of error there goes in the shaded region. Alpha is 0.05. Now our next step is to identify, let's see if I can get that to right. Our next step is to identify the critical value. That is our step 2. We are looking for the critical value. And we get that from a chart. So if you've looked at the overview, you know when we're looking for averages or means and the sample size is 30 or more, we are using the Z table. So let me pull that up real quick. Now the Z table looks like this. And notice the picture at the bottom. The Z table is 2 parts. Here's the negative side, here's the positive. The picture at the bottom reads to the left. What we are doing reads to the right. So we must do 1 minus before we look this up. I need it to read to the left. The whole thing represents 100% or 1.0. So I'm going to do 1 minus 0.05 and I get 0.95. So I'm looking up the closest thing to 0.95. Now remember, add a couple zeros. Because there are 4 digits in the chart, it's just easier to add a couple zeros to the end. We're looking up the closest thing to 9,500. So inside our chart, right here is 5 below, and this is 5 above. Now remember, the textbook that my class is in tells you to go to the right. Always go to the right. Okay? You don't average them in this textbook. So we are going to do 1.6. Because there was a tie, I went to the right. 1 was 5 above, 1 was 5 below. And up here, my next digit would be 5. So it is going to be a positive 1.65 for my critical value. So I'm going to put that critical value right here. There will also be a blank on the test that I give you for your critical value. Okay, so I have 1.65 here. My next step, let's get a different color. Next step is test value, step 3. Now again, we are looking at means or averages, okay? And my sample size is 30 or more. So we are using the Z-score formula where it says you are doing X bar, mean of the sample, minus mean of the population, mu, over standard deviation of the population divided by the square root of the sample size. So let's put that in. Mean of the sample was 47.8. I don't know why my thing doesn't want to write decimals today. 47.8 minus the mean from up above the population. When I say above, I mean step 1. That was 46 over standard deviation, 3.6, divided by the square root of 30, which is the sample size. When you plug that in your calculator, you should get 2.74. Sorry, having trouble with decimals today. 2.74. Let's go over here and let's see where that would fall. That is greater than 2.75, or sorry, 1.65. So it's going to go here. That'll be somewhere in there, my 2.74. Okay, so now we're going to do step 4 and step 5. Now remember, step 4 is always about the white area. It's always about the null, which is the white area. H sub 1 represents the shaded area. H sub 0 is the null. So look at the null. If it is empty, if the white area is empty, you reject the null. So we are going to choose to reject the null. Remember, if there is a line there, I'm talking about the green line, the test value is there, then if it is not empty, you do not reject the null. Okay, let's do step 5. Now step 5 talks about the claim. So go back to step 1. Did they claim the white area or the shaded? They claimed the shaded. Go to the shaded and look for your evidence. That test value, that green line is your evidence. It's in the shade. So we are going to choose there is enough evidence to support our claim. If the test value had been over here, then there would not have been enough evidence to support our claim. It would be in the wrong area. So you look and see what they claimed, and that's where you go to find your evidence. Since they claimed the shaded, and the evidence is in the shade, there is enough evidence. If that green line had been over here, I would put there is not enough evidence to support the claim.